So, this is a lecture on computer networking, top-down approach, 7th edition by Cruz and Ross. So, what's the goal of this chapter? Get, feel, and the terminology. More depth, detail later in this course. Use approach. We use internet as an example. What's overview of the introduction? What's the internet? What's a protocol? What's network edge, host, access net, physical media? In network core, we have packet circuit. So what is a network edge? The host devices, the access nets, and the physical media. Whereas the network core consists of the packets and the switching of packets and internet structure. Performance is calculated using loss and delay throughput and the security over the network, protocol layers and service models, and the history of. What Now we will see what is the internet. What is the internet? The nuts and bolts view of internet. Billions of connected computing devices. There are billions of connected computing devices that are known as host or end systems, which runs network applications such as www.http, https, www. Some website, everything are network apps, and these are communicated and connected using the communication links such as fiber, copper and radio satellite. The transmission rate is measured through bandwidth. So how we measure the transmission rate? We measure the transmission rate through the bandwidth. The packet switches. Forwards packets. What are packets? Chunks of data. A chunk of data is known as packet. If we have a message, we send a message, and that message is broken into many chunk of it. That message is actually zeros and ones, right? Which are further broken into some packets of data, specific chunks of data, and these are transmitted through the routers and switches. So the fun internet connected, what are the possible internet connected devices? IP picture frame, weather toasters, link box, internet refrigerator, IoT, the importance of Internet of Things, sensorized bed mattress, internet phones, and Twitter what monitor energy use. So what's internet? Internet is a network of networks. So this is a network, and the network of the network is known as internet. Interconnected ISP. ISP stands for Internet Service Provider. Protocols. Protocols are control sending and receiving of messages. They are like rules. Protocols are nothing but rules which control the sending and receiving of messages. Example HTTP, IP, TCP, Skype, 802.11. So what is TCP? TCP is Transfer Communication Protocol. IP is Internet Protocol. Hypertext Transfer Protocol, Skype, and this is Wi-Fi. Wireless fidelity is also known as Wi-Fi, which is also known as 802.11. What are the internet standards? Internet standards are request for commands, RFCs, request for commands, RFCs, and IETF, Internet Engineering Task Force. So these are the internet standard deciding authorities. What are the authorities which decides the internet standards? RFCs, request for commands, and IETF, Internet Engineering Task Force. Internet Engineering Task Force. So what's internet? We see the nuts and bolts view. What about the service view? An infrastructure that provides services to applications. So internet is an infrastructure that provides services to an application. We run a web app, and the web app, where does the data it gets from? Or you are sending message from that web application to your another friend who has that web application. How does that message reaches there? It's through the network. So internet is an infrastructure that provides services to applications. So web, voice over IP, email, games, e-commerce websites, and social nets are example for the services provided by the internet, and provides programming interface for apps, hooks that allow sending and receiving program apps to connect to the internet. So provide service options analogous to postal services. So email. What's an email? How does this network of network works? So you write an email which has to address and from address, right? To and from address. So this carries the message from your computer to your friend's computer, and from here the email will be packed and sent as packets and chunks of data, which will be forwarded like this, and from here they will be forwarded to their respective routers through the shortest path and reach here, and this router will ensure that these packets should reach here, just like how postman delivers the mail to the courier or mail to the end recipient. What's a protocol? Humans do have protocol. So if I ask a question, what's our time? I have a question, introductions. So specific message sent and specific action taken when the message is received or the other events. So protocols define order of messages sent and received among the network entities. So protocols are defined format, order of messages sent. So the format of the message, we are sending a message means what is its format, order of messages sent and received among the network entities, and the actions taken on the message transmission and receipt. So first we will take about the format of the message and order of the message sent and received among the network entities, and the action taken on the message transmission and the receipt. The machines rather than the humans. In network protocol, we talk with machines rather than humans. All communication activities in the internet are governed by the protocols. So what's a human protocol? So she asks, she sends hi, and he replies hi. She has got the time, he replies as 2 o'clock. And this is a human protocol. If we get hi, we should reply back hi. That's a basic human protocol. Basic human protocol. And if someone asks time, we have to reply them the time. And TCP connection request. So this computer connects with the server through a TCP connection request, and the server gives a TCP connection response, and it gets the particular website, and we get the file from the, we ask the server for the particular website, and the server will send the particular file. So what's the network edge? So we're going to see about the network edge. What's a network edge? We will see the end system, access networks, and links. So network edge. So close look at the network structure. What's the network edge? Host. Host means we have clients and servers. Host are end devices which have clients and servers. And so global ISP, regional ISP, home network, and further on. Access network, physical media network. So there are two types of communication: wired communication, wireless communication. Wired communication and wireless communication. Network core, interconnected routers, or network of networks. What is network of networks? Networks of networks is nothing but the internet. Network of networks are nothing but the internet. So how to connect end system to the edge router? So how to connect an end system? This is an end system to an edge router. Edge router. This is an edge router. This is an edge router. These are edge. This is an edge router. And residential access nets. So we have this here. It is residential access nets, and this one is institutional access network or schools or companies, and this one is mobile access networks. This is global ISP, and this is regional ISPs. Keep in mind bandwidth, bits per second of access networks, shared or delegated. So access networks, digital subscriber line, DSL. So DSL is also a DSL modem. So here we have an internet service provider. From the internet service provider, we get through the telephone network, we get through the central office. And in the central office, we have the DSLAM. From the DSLAM, we transmit voice and data at different frequencies over a dedicated line to the central office. And this is sent to the home. From the home, we have a splitter which splits the voice over IP to the telephone and the remaining to the DSL modem. This is DSLAM is a DSL access multiplexer which connects every home from every house to the internet service provider. So use existing telephone line to central office DSLAM. And so what's DSLAM? DSL access multiplier is shortly known as DSLAM. And data over DSL phone line goes to the internet. Voice over DSL phone line goes to the telephone net. So when it is less than 2.5 Mbps upstream rate, and less than, it is always less than 24 Mbps downstream rate. So upstream 2.5 Mbps upstream and 24 Mbps downstream. Typically 1 Mbps and 10 Mbps only. It's an overrated case, I think so. So what's happening here? Cable network. So we know the cable TV, right? What's the cable network? So we hear the cable head divider, and it provides to every other house. And from here we will have the splitter and the cable modem. And in this wire we have 9 channels and frequency division multiplexing. Different channels are transmitted in different frequency bands. So different channels are transmitted in different frequency bands. The first 8 channels contributes to the video, the next 2 contributes to the data, the last one contributes to the control. So different channels are multiplexed using frequency division, and next one we have HFC, hybrid fiber coax. So what is a hybrid fiber coax? Asymmetric. It's an asymmetric. Up to 30 Mbps downstream, transmission rate, and 2 Mbps upstream transmission rate. So fiber coax we have 30 Mbps downstream transmission rate and 2 Mbps upstream transmission rate. And network of cables, fibers attaches homes to the ISP routers. So the network of cables and fibers. So this cables and fibers attaches to the ISP router. Homes share access network to the cable headend. All these homes share access network. These are access network to the cable headend. Have access network. Shared access network. Unlike DSL, which have a dedicated access to the central office, data TV transmitted at different frequency over a shared cable distribution cable. Cable modem termination system. Cable modem termination system is also known as CMTS. To or from head end or central office. Cable or DSL modem. Router, firewall or NAT. Network address translation. Wired Ethernet 1 gigabytes per second. Wireless access 54 megabytes per second. And wireless devices of these wireless access point and the router firewall are usually combined in a single box. And enterprise access networks are also known as Ethernet. Enterprise access network are also known as Ethernet. So these are Ethernet switches. So this is an institutional link to an ISP. So Ethernet is an enterprise access network, is also known as Ethernet, typically used in companies, universities, etc. It has a wide range of networks with 10 megabits per second, 100 megabytes per second, 1 gigabyte, and 10 gigabyte transmission rates. Today, AN systems typically connect into Ethernet switches. And AN systems typically connect into an Ethernet switch. Institutional mail or web servers. So wireless access network. Shared wireless access network connects an system to router via a base station, also known as access point. These wireless access networks connect the end system through the access point. So this is known as access point. AP, aka AP, base station. To the router. This is connected to the router. Within the building, wireless LANs are connected within the building. So 8.0.8.2.11 B/G/N, also known as wireless fidelity, gives 11,54,450 megabytes transmission rate, whereas the wired area wireless access. So what is a wired area wireless access? Provided by the telecom service, cellular service operator, which has a radius of if from here the access point, there's a radius of 10 kilometers. and between 1 and 10 megabytes per second. Here we will get 11,54,450 megabytes. Here the maximum range itself 10 megabytes per second, and the 3G and 4G, also known as LTE, low transmission interrupt. Host sends packets of data. So the host breaks the message into two. Here it breaks into two packets and it sends. Host sending function takes an application message, breaks into chunks, smaller chunks, also known as packets, of length L bit. So the packets have a length of L bits. Transmission transmits packet into access network at transmission rate R. So the link transmission rate is R. So these packets are sent from the host through into the access network at a transmission rate which has a link transmission rate R. Then the link transmission rate AK is also known as capacity. It's also known as capacity. It's also known as the capacity and also known as the link bandwidth. Link bandwidth, also known as the link bandwidth. Packet transmission delay. So what is a packet transmission delay? Time needed to transmit L bit of packet into the link. So what's the time needed to transmit L bit of packet into a link is known as packet transmission delay, which has an we usually divided the L length of the packets divided by R. If we transport two packets, then it is 2L by R. Physical media. Bit propagates between the transmitter or receiver pairs. So bit is a 0 or 1, which transmits between the receiver pairs. And physical links. What lies between the transmitter, which sends and which receives? Whoa, so what lies in between these two is known as the physical link. And there are two types of physical link: guided media and unguided media. Guided media uses the wired. Guided media are wired connections. Unguided media are wireless connections. So unguided media are wireless connections. So why we call the wired media as guided? Because the signal transfers in a guided path. Signal propagates in a solid media such as copper, fiber, and coax. And in unguided media, that is a wireless connection, signal propagates freely. It might go in any possible direction. Therefore, we term it as an unguided media. And twisted pair. Then two insulated copper wires are twisted. And these usually are form of four pairs of two twisted four of twisted pair copper wires encapsulated in a rubber or stuff, which is this has a two types: category 5 and category 6. Category 5 is of 100 Mbps or 1 Gbps Ethernet, whereas category 6 is of 10 Gbps Ethernet. So whereas 100 Mbps or 1 Mbps, 1 Gbps Ethernet, and the category 6 is of 10 gigabytes per second of data could be transmitted. In the physical media, we will see first the coax cable. Coax cables. This is a coax cable which has so this is the major part through which the transmission occurs. Two concrete copper conductors, bidirectional. It could go in this way or it could transmit data in this way. Broadband, multiple channels on a cable. You could transmit multiple channels. This is alright, channel 1, channel 2, but on multiple frequencies you could travel. So what's HCF? What's HCF? What we saw about HCF? Hybrid fiber coax, 30 Mbps downstream and 30 Mbps upstream. So HCF, hybrid, what's an HCF? Hybrid fiber coax is also known as HCF, and which has a 30 Mbps downstream rate and 2 Mbps upstream rate transmission rate. So next we will see fiber optic cable. Glass fiber carrying light pulse. Each pulse has a bit. If it glows, it's 1. If it glows, it's 1. If it does not glow, it's 0. So at each pulse, at each second, if it glows, it's 1. If it not glows, it's 0. That's how the fiber optic cable transmits the data. High speed operation. The data could be transmitted at the speed of light because it travels as light. And the high speed of point-to-point transmission. 10 milliseconds, gigabytes, tens and hundreds gigabytes. So tens and hundred gigabytes transmission rate. Whereas in the the previous stuff, the maximum so twisted pair cable, the maximum is 10 gigabytes per second. But here its transmission rate is 100 tens and hundreds gigabytes per second transmission rate, and it has a low error rate. Since the repeater space far apart, the repeaters are not needed because it does not have interference. It has also immune to electromagnetic noises. Therefore, it has low error rate. Next, we see the physical media, which we are seeing is radio. Signal carried in electromagnetic spectrum. This is a signal which is carried in the electromagnetic spectrum. EM wave, which is carried as an EM wave. So it is carried as an EM wave. No physical wire. There is nothing known as a wire here. It is bidirectional. Since it could go in any way. It's multi-directional actually, but it is bidirectional. And propagation environment affects reflection. It is what are the environmental factor which affects the propagation of radio waves, reflection, obstruction by object, and interference. Radio link types: terrestrial, microwave. So the first type of radio wave is terrestrial microwave. It could transport up to 45 megabytes, maximum itself the 44 megabytes per second channels. And the LAN, the Wi-Fi fidelity is a radio wave actually. It transports up to 54 megabytes per second. The wide area network, which is the 4G cellular, is about 10 megabytes per second. And the satellite, kilobytes per second to 45 megabytes per second, or multiple smaller channels. 217 milliseconds end-to-end delay you could observe in the satellite. Geosynchronous versus low altitude. There are two types of satellites. One is geosynchronous, another one is low altitude. What is a network core? Packet switching, circuit switching, network structure. So network core, mesh of interconnected routers. So till now we've seen about the host devices. Now we are going to see about the network core. So what is a network core? This is a network core. Network core is a mesh of interconnected routers. This is a mesh of interconnected routers. Packet switching, host break application layer messages into packets. So in a host, if this is a host, so this is a host. In this we have many OSI layer. The topmost layer is an application layer, and here the host breaks the message. Here it will be as a message, and the host breaks it into packets of data in the application layer. Forward packets from one router to the next across the links on the path from source to destination. So these packets are forwarded from one router. These packets are forwarded from one router to the next router across the link on the path from source to the destination. So from here it goes like this reaches here and reaches this. So each packet are transmitted at the full link capacity. And this is a link, and the packet is transmitted at the full maximum link